Okay, so for 13.2, we're going to hit a couple of different sections today. 13.2, we're going to talk about angles. The big thing with angles is they're going to talk about standard position. And basically is this, when we're talking about everything here with the angles, standard position is when angle has the vertex at the origin and one of the rays is on the positive x-axis. And the angle that's on the positive x-axis, they always call that the initial side. So the beginning side, which is what they call the initial side, it always has to be on the positive x-axis. The other side that you would, because again, if you draw an angle, you need two rays that go with this thing. The other ray can be in any position, anywhere that you want to go with it. And with that ray, they just call it the terminal side. And it can be anywhere it wants to be. Now, the only thing is that ray has to also have its vertex at the origin. But that's what we're going to kind of look at. And what we're going to do is we're just going to sketch you some different, or have it so that you have to sketch some angles, and we'll show you some different things of how this is going to set up with it, so you can kind of see what it is that they're asking you to do when we go through the parts in this thing. Okay, as you do these, a couple of things you have to know. When you sketch the angles, because you basically have two options for this thing. You either have positive angles or you have negative angles. Positive angles are drawn up from the initial side. And negative angles are drawn down from the initial side. Okay, and we'll show you exactly what that means when we go through these. And it's one little minor difference. And again, once you see a couple of them, you can tell exactly what it is that we're looking at. Okay, so let's say you're asked to sketch something that's 30 degrees. Okay, and again, you'll basically be given an XY axis for this part of it. And then what you're going to see is you'll have, we'll do this one in red so it shows up a little better. This would be your initial side. You're going to start at 0, 0 at the origin, and your initial side will always look like that. So even back here where we're talking about the initial side back up here, probably should have drawn that so you could see that the initial side would look something like that every time. That's always going to be the initial side. You'll have a dot that's on the left, and it's drawn out to the right of it. So when we're asked to sketch 30 degrees, same thing. We'll start at the origin that's going from here. If it's positive, and here's how they'll kind of show if it's positive or negative. If it's positive, they'll have an arrow that's pointed in the up direction. May not be a very big arrow, but it's just still an arrow that's here. And basically, you just have it so that this thing goes up about 30 degrees. Okay, so there's an example of a positive angle. That basically, if you start here, the arrow is going to go pointed in the up direction. Let's do the same thing, but make it a negative angle, just so you can see the difference of the two. Okay, the initial side will be exactly the same way. You'll still start here at the origin, and it's still going to point over to the right side. So that's the one thing that's always the same. Doesn't matter what angle it is, positive, negative, if it's a small angle, if it's a big angle, it doesn't matter. It's always going to start in the origin, always go to the right side. If it's negative, just means you're going this way. So you could almost say that when we're doing positive angles, they're going to go counterclockwise. If you have a negative angle, then those are going to be clockwise. Okay. And if we're just sketching these, most of the time it's going to be either, a lot of times it's going to be multiple choice, that they'll give you an angle and they'll say, pick the angle that's 30 degrees. Or they'll make it so that you don't actually have to draw anything. Same thing for the ones that we do, we're doing a test. You won't actually have to draw it. It'll just be, pick which one of these is a 70-degree angle, and you just got to kind of do a best guess on this one. Okay, now here's where we're going to start doing some radians. Because this is the part that, again, that we're kind of angles, degree angles, everybody's usually pretty good with it. It's pretty straightforward. When we start talking about radians, this is where people start to struggle just a little bit. And this is, again, where it's good to have out your unit circle that we had from yesterday. Probably the easiest thing to do at this point is if you have your unit circle that we drew yesterday, and I'll put one of these online so you can see, so that it's nice, and it's, not that it's got a lot of color to it, but it's nice and clean so you can see everything that's here. Basically, you just find 3 pi over 2 on the graph. That's right here at the bottom. That's the same thing as 270. So when you're sketching this one, you can basically say that, all right, this would be the same thing as sketching 270 degrees. It is positive. So after we draw the initial side, you have to go in this direction. And you can almost just basically count it off. Every time you get to one of these lines, you're going an extra 90 degrees. So if we went this far, this would be 90. This would be 180. We'll keep going until we get to 270 degrees. So that would be how you would sketch an angle that's 270 degrees, or that's how you would sketch 3 pi over 2. Yeah, if it went, if it was 360 degrees, yeah, this thing would go around and make a full circle. So that's basically what you're doing, is saying, all right, if you start drawing a circle from here, how far are you going to go?
So how do we show on the angle?
Well, the arrow that's here, when you draw this arrow, because basically you'd have an arrow that would this one would kind of blend in because it's on the axis, but you'd have another angle that would kind of be drawn there. That one would be hard to see. Really, the only way you'd be able to see this one is that you've got this red arrow that's drawn from here to here to let you know you're going this far back around to it. All right, let's give you one more of those. Let's do a negative here. Let's sketch negative 5 pi over 4. Okay, and again, go ahead and draw the initial side because we know that has to be there. Okay, and again, if you're not sure exactly where it is, go in and find 5 pi over 4 on your unit circle. That's right here. That's the same thing as 225. And since it's negative, well, that just means it's negative 225 degrees. And since it's negative, we know we have to go this way, so you basically start here and you start going down. Well, if we go to here, that's 90 degrees. This would put us at 180. If you get all the way back to here, this would be 270, so 225 should be somewhere in the middle, so we'd kind of stop here. Have a line that would look something like that. Okay, And the biggest thing is with the arrows is that the arrows tell you basically what number you're going to do. Because if you, let's just kind of show you what would happen if you did not have the arrow drawn for this part of it, when we did these. If they didn't draw the arrow, I'll do this on the side over here. If they gave you an angle that was like this, which one would it be? Well, you don't really know, because did you go this way or did you go this way? So that's the whole purpose of this one, is to know, because you could kind of go either way on that one. It's kind of like we're talking about making a circle, that if you go clockwise or counterclockwise, eventually you wind up at the same spot. So basically they put the lines in here to let you know, all right, does it talk about this angle that was positive, or am I talking about this angle that's negative? So that's why you always have these arrows that's kind of drawn here, so you can know exactly what it is you're talking about. Okay, now this little drawing that's here kind of takes us to the next thing that we have, because the next thing that we're going to talk about with this one, with the arrows and the angles and everything that's here, is coterminal. And with coterminal angles, now the terminal basically in this part means it's ending. So these are angles that end in the same spot, if you want to think about it this way. So these are angles that end at the same side. When we're talking about the same side, we're basically saying they end at the same location. It's just one of them is going to go up, the other one is going to go down. So it's basically the same thing as this one. These would be two different coterminal angles. One where we're using the positive side of it, one of them where we're going to use the negative side. So that's the image that you want to think about when we're doing coterminal. They're both in at the same location, just one's going positive, one of them's going to go negative. Okay. And the biggest thing that they're going to do when they talk about coterminal angles is that they're going to have you kind of figure out where these angles are and what they're going to do with these. So to find coterminal angles that are between 0 and 360, you're going to do either one of two things. If the angle is positive, you're going to subtract 360. And if the angle is negative, then you add 360. Okay. And again, because it's a circle, eventually you're going to make a circle all the way around in one direction or the other. You're always going to do something with 360. So if the number is positive, you subtract 360 from it. If the angle is negative, then you're going to add 360 to it. Okay, so what we're going to do first is we're going to do two things with this one. We're still going to do a sketch, but then at the same time, we're going to find a coterminal angle. So we're going to sketch negative 135. And then we're going to name a coterminal angle. Okay, now, and occasionally they might even leave this out so that there is no XY axis. It may just be an angle being drawn without anything else all with it. So on this one, the big thing is, again, if it's negative 135, this would be your initial side that we have to go down. Well, if we stop here, this would be at 90 degrees. So we got to go a little bit past 90 again, we know 180 would be this part. So basically somewhere between 90 and 180, we're going to have to stop. So we'd have to look something kind of like that. Okay, so there's a negative 135 sketch. And then to find the coterminal angle, if it's a negative number, it's really pretty simple. You add 360 to it. There real quick, that comes out to be 225. There you go. Okay, and again, what that really means is that, okay, if we did this negative angle that was negative 135, if we were to find an angle that was positive that would wind us up in the same spot, it would be this angle that would go here, and that angle would be 225 degrees. So negative 135 would be here, positive 225 would be there. And that's basically, and again, that's kind of what you were saying a minute ago, is that if you put these two things together, it should wind up making a circle when it comes down to it. Okay, I'm going to take that away just because, we were just stopping with that sketch that was here. Again, most of the time when they do this, they don't put the angle measure on it. They'll just leave it like that so that we know that that's what that would be. Okay, so here's what we're going to do for the last couple of pieces. On this one, we're not going to do any more sketches because I think everybody's sketch-wise, we're good. For these, we're just going to find a coterminal angle that's between 0 and 360. Try the bottom, so let's that up a little bit. Okay, and we'll do 4 or 5 problems because once you see 4 or 5 of these, we can pretty much be done with everything else today. Okay, again, if it's negative, only one thing you have to do is just add 360 to it. There you go, 80 degrees. Okay, and if it's positive, take that number and subtract 360. Okay, and the closest thing to a trick question that they can do on these is they may give you a number that is negative 560. Okay, and again, if it's negative, it's pretty straightforward. Just take that number and then you add 360 to it. All right, comes out to be negative 200. And then you may go, well, all right, but then it says, the answer says it has to be between 0 and 360. That's not between 0 and 360, right? Still negative? So if it's still negative, guess what we do? There you go. You just add another 360. So you just keep adding 360 to the number until eventually you finally get an answer that's somewhere between 0 and 360. You might have to add it 3 or 4 times. Doesn't matter what you do. Just keep doing it. Just keep adding it, keep adding it, keep adding it until eventually you get a number that's between 0 and 360. Same thing if it was a positive number. If it was 975 degrees. Well, you'll take that number and you'll subtract 360. All right, we'll do that real quick. That is 615. It's not between 0 and 360, so we'll do it again. That comes out to be 255, and that is between 0 and 360, so then we're good to go. Again, if that had been like 455, just keep subtracting 360 till eventually it comes up between 0 and 360. Okay, and probably the hardest things that you have to do for these when we're doing the conversions on this part is, I'm going to run out of room here, so I'm going to go to a new sheet, is that when you're doing these, if they give you a number that's in radians, and this is the first that we've done anything with radians, and so most time people get this and they're like, okay, I'm not really good with this, so I don't know what to do. Okay, here's what you're going to do. Kind of do like we did before, is that we're going to go back to your unit circle, find out that 11 pi over 6 will basically be the same thing as 330 degrees. So it's negative pi over 11 pi over 6. That's the same thing as negative 330. Okay, so then to fix that, it's a negative number. We need to add 360 to it. So that puts us to 30 degrees. Okay, now the thing is that when they give you the answer that's in radians with the pi in the answer, we've got it in degrees. We got to change the degrees back to radians. So you can either do one of two things. Either you can do the conversion formula we talked about yesterday, but since that number is on the unit circle, we can say, all right, with 30 degrees, that's the same thing as pi over 6. So then we can just go back and say, all right, well, then that's just going to be pi over 6. Okay, so that's kind of what they're doing as far as, again, getting numbers so that they're between 0 and 360, just in kind of reference point. That's kind of what we're looking at. Again, if it's a bigger number, you just keep working with the 360 until you get it to be between the numbers that it needs to be. Okay, and then one last little thing that's, I think this is more, I forget exactly where this one is. There's one little section of homework. This is like really straightforward, really easy on this one. It doesn't really fit here, but I couldn't find a better spot to put it, so we're just going to put this one here. To find an intercepted arc. Again, arc is just a part of a circle. You're going to multiply the radius and the angle. Okay, so you're going to multiply the radius and the angle. And the way this is going to look, it's going to be really straightforward when you see these, because they're going to give you a chunk of a circle like this, and then they're going to tell you that this angle is pi over 2, and that the radius right here would be 11 inches or 11 meters. It doesn't matter what it is. Inches, feet, doesn't matter really when it comes down to it. All you have to do is, here's your radius, here's your angle. Just multiply those two things together, and whatever that number comes out to be, that's your answer. That's all you got to do. Okay, so for this one, give it a big angle here. 5 pi over 4, and then the radius is 8 meters. Okay, and again, pretty much every single time they give you two numbers, you just take those two numbers and you multiply it together. This is when it kind of comes out where you have to do a little bit of work, because you do have 8 divided by 4. So you can cancel that out and make it 5 times 2 for 10 pi. Okay, and that's it. That's intercepted arc. Is very straightforward. They give you two numbers, you multiply the two numbers together, and that's all that you have to do.